fractional oxidation state. Okay, so here we studied about fractional oxidation state. So in some compounds we get oxidation states in fractional form. So for we have to take some examples. So in the one example is S4O6 minus 2. Okay, so its name is sodium tetrathionate. It is tetrathionate ion. So if you take sodium, Na2S4O6 also present, it is called sodium tetrathionate. Now we are in place of sodium, we take minus 2. Okay, so you see S4O6 minus 2 tetrathionate ion. Okay, so in this tetrathionate ion, you want to find sulfur oxidation state. If you find average oxidation state, 4 sulfurs are present. So here we want to find sulfur oxidation state, that's why we write 4x, and 6 oxygens are present. 6 oxygen means 6 into oxygen is present in oxide form. Whenever oxygen is present in oxide form, its oxidation state can be taken as minus 2. That's why here minus 2 equal to, and here charge is present, the charge is minus 2. So after equal to write minus 2. So it is 4x minus 12 is equal to minus 2. Okay, minus 12 this side we write plus 12. Plus 12 minus 2 means 10. So 4x is equal to 10. And from this x is equal 10 by 4. 10 by 4 means nothing but 5 by 2. 5 by 2 means it is 2.5. Okay, so it is a fractional order for tetrathionate ion. In tetrathionate ion, sulfur fractional order is 2.5 and it is called average oxidation state. Okay, here 4 sulfurs are present. For that 4 sulfurs, average oxidation state can be taken as 5 by 2 or 2.5. Okay, and here 4 sulfurs are present. If you want to find individual oxidation state for each sulfur, we can write the structure of tetrathionate ion. Okay, if you write structure, total 4 sulfurs are present. So we take 4 sulfurs. Okay, and in these oxygens can be present like this: double bond O, double bond O, and here O minus is present. Here also same, double bond O, double bond O, and here O minus is present, and remaining bonds can be present like this. Okay, it is the structure of tetrathionate ion. And you see in this structure, S double bond O means oxygen contains minus 2, oxide form. S double bond O, oxygen minus 2, and here O minus means already oxygen contains minus 1 charge, that's why here remaining minus 1. Okay, so minus 2 minus 2 minus 4 minus 5. So here sulfur contains its oxidation state as plus 5. Okay, similarly here also same, right? Minus 2 minus 2 minus 1. So the sulfur contains plus 5 oxidation state. Okay, and here you see these two sulfurs are present middle. These two sulfurs, whenever they are directly attacked, this oxidation state can be taken as 0. Okay, so in total S4O6 minus 4 sulfurs are present. One sulfur plus 5 oxidation state, another sulfur plus 5 oxidation state, and sulfurs which are present in the middle, this contains 0 oxidation state. Okay, if you want to write total oxidation states, we can write like this: plus 5, 0, 0, plus 5. Okay, so these are the oxidation states for individual sulfurs. Okay, if you take average oxidation state, 5 plus 5, 10, total it is present 4 times, that's why we write the average oxidation state as 10 by 4. Okay, that is this 10 by 4 is the average oxidation state, that means 5 by 2 or 2.5. Okay, so in examination you are asking to find about average oxidation state is given in the options, then you take 5 by 2 or 2.5, and if you are asking to find each sulfur oxidation state, in that condition we take plus 5, 0, 0, plus 5. Okay, these are the individual sulfur oxidation state, right? Now we take another example to explain about fractional oxidation state. So second example, in fractional oxidation state, second example you take C3O2. C3O2, it is called carbon suboxide. In carbon suboxide, total 3 carbons are present. If you want to find the average oxidation state, here 3 times it is present 3x, and oxygen it is 2 times, so write 2 into minus 2, and here there is no charge, that's why after equal to write 0. So total 3 carbons means 3x, 2 oxygens, 2 into minus 2. Okay, so from this we write 3x minus 4 is equal to 0, 3x is equal to 4, and you see x is equal to 4 by 3. Okay, so here 4 by 3 means it is nothing but 1.33 like this. You have to get the average oxidation state in C3O2. Okay, so in C3O2, the average oxidation state is 1.33 or 4 by 3. It is a fractional oxidation state. Total 3 carbons are present. Okay, and if you want to write individual carbon oxidation state, in that condition, we write the structure of carbon suboxide. Okay, if you write the structure, it is present like this: C double bond O, C double bond O, double bond C, double bond C. It is the structure of C3O2. Okay, right here oxygen is present as oxide, that's why it contains -2 oxidation state. So here -2 means this carbon contains +2 oxidation state. Okay, here oxygen oxide form -2, so this carbon contains +2. Okay, right now you see carbon, 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 3 carbons present in a sequential manner. In that condition, middle element which is present, that can be taken as oxidation state 0. Okay, so here 3 carbons, +2, 0, +2. Okay, so if you write a separate oxidation state, +2, 0, +2, these are the 3 oxidation state. And if you want to write average oxidation state, 2 + 2, 4, and it is present T times, means total 4 by 3. It is average oxidation state in C3O2. Okay, so if you write average oxidation state, that is 4 by 3. And if you want to write individual oxidation state, in that condition you can take +2, 0, +2. Terminal carbons, they are having +2, +2, and the carbon which is present in the middle, its oxidation state can be present as 0. Okay, right, it is second example. Right, now we take another example, third one. Right, third example, Br3O8. Okay, bromium present in 3 times, so we write tribromo. Oxygen, it is present 8 times, octa, and it is oxide. So it is tribromo octa oxide. Okay, if you write average oxidation state, bromine, it is present 3 times, 3x. Oxygen present 8 times, 8 into -2 is equal to, there is no charge. No charge means 0. So from this, 3x minus 16 is equal to 0, and 3x is equal to 16, and you write x is equal 16 by 3. 16 by 3 means we get 3 5 are 15, 5.33 like this. Okay, so if you write fractional order in Br3O8, that is 5.33 something, or we take average 16 by 3. Okay, it is fractional oxidation state or average oxidation state in Br3O8. Okay, if you want to write individual oxidation state for each bromine, in that condition we write the structure. Okay, total 3 bromines are present, Br, and here 8 oxygens. These 8 oxygens can be present like this: double bond O, double bond O, double bond O. And here this terminal bromine also contains 3 oxygens. Okay, right, now remaining 2 oxygens are present on middle bromine. It is the structure of Br3O8. Okay, oxygen contains -2, so -2, -2, -2, -2, -2, total -6. So bromine contains +6 oxidation state. Okay, in middle bromine, here -2, and here also -2, -2 means here +4 is the oxidation state, and here you see -2, -2, -2, so this bromine contains +6. Okay, so if you write individual oxidation state, those are 6, 4, 6. Okay, 6, 4, 6 are 3 bromine oxidation state. If you take average oxidation state, 6 plus 4, 10, 10 plus 6, 16, and total it is 16 by 3. It can be taken as average oxidation state. Okay, so it is another example writing fractional oxidation state. Okay, and you see in some metals that are present in combined form, those are also having these fractional oxidation state. Okay, here that metals actually that are in mineral form, that are oxide form, that are available in a combined form. Okay, if you take an example for that, we take Fe3O4. Okay, Fe3O4 iron oxide. In this you take 3 irons are present. If you write average oxidation state, 3x, and 4 oxygens are present, 4 into -2, that is 0. So 3x minus 8 is equal to 0. From this, x is equal to, we write 8 by 3. Okay, 8 by 3 means we get 3 to just 6, 20 means 2.6 like this. Okay, so it is a fractional oxidation state in iron. 3 oxygens are present. Average you have to take in 2.6 or 8 by 3. Okay, actually here Fe3O4, this iron oxide is, it is a combination of 2 oxides, that is FeO, ferrous oxide, Fe2O3, ferric oxide. Okay, actually by combining this we get Fe3O4. So if you want to write individual oxidation state, we can write that it is a mixture. By mixing these two we get this. So here we can find individual oxidation state. Okay, so you see in FeO, iron oxidation state, iron can be taken as X. For oxygen it is -2 is equal to 0. So X is equal to, we take +2. So in FeO, iron oxidation state can be taken as +2, and in Fe2O3, ferric oxide, so here iron present 2 times 2x plus 3 oxygens, 3 into -2 is equal to 0. So 2x minus 6 is equal to 0, 2x is equal to 6, x is equal to +3. Okay, so your oxidation state is +3. Okay, so we take like this. It is a mixture of FeO and Fe2O3. In FeO, its oxidation is +2. In Fe2O3, it is +3. Okay. So here, if it is present as a mixture, it having 8/3 is the oxidation state. Okay. So it is also an example for fractional oxidation state. Here, oxide, iron oxide or lead oxide, these are actually mixtures of two minerals. Like this, Fe3O4 is a mixture of FeO plus Fe2O3. So if you have to write average oxidation state, we take 8/3. Or if you want to write individual oxidation state in these compounds, for FeO +2 and Fe2O3 it is +3. Okay, so these are some examples for fractional oxidation state. Okay, in examination in options it is given average oxidation state, then directly we can write what is the average oxidation state, that can be taken as the answer. Okay, or in options it is given individual oxidation state, and the problem it is asking to find individual oxidation state. In that condition, compulsory we write the structure. From that structure only we can get the individual oxidation state of each element in that fractional oxidation state compound.